Good morning, folks. This is Jason Fassini with IBM's Hybrid Cloud Sales Team, and welcome to this week's Integration and Development webcast. Today, we are pleased to have Kim Clark rejoining us. You may recall Kim had led a multi-part Agile integration architecture series late last year, and today we've asked him to rejoin us and provide a version of the presentation that he delivered at the recent Integration Tech Conference, probably about 6 to 8 weeks ago now. In today's presentation, we'll be focusing on how to best scale integration. So this is also going to be a brief multi-part series. What Kim will be presenting today is more of the architectural concepts and considerations around scaling integration. And then I expect next week we're going to have one of Kim's colleagues from the offering management team join us in lead part 2, where we're really looking at some of IBM's specific solutions from the integration and development portfolio that'll help you along this path. So I know we do have a hard stop today at about 25 past the hour, so I'm going to hand things over to Kim, but just wanted to remind folks that we're going to have the chat open throughout the session, so if you have any questions, feel free to submit them. We can make an attempt at addressing them before we reach the end of today's session. But anything we don't get to, I will collect, and either Kim or myself will follow up with the answers you need a bit later today. So with that out of the way, I'm going to hand things over to Kim, and we can get started.
Great, thanks, Jason. And so, yeah, the topic I wanted to cover here is really sort of following on from those previous discussions on Agile integration, but looking at the integration architecture as a whole and how we manage the fact that the type of applications that are being written today are much more innovative and experimental and very likely to come with an unknown performance requirement. And so the need to be able to scale elastically and move effectively around across the hardware that you're dealing with is really becoming critical. Not knowing what the workloads are going to be in the future is something that we've been trying to deal with for some time now. In fact, if we look at, we go right back, we started with bare metal machines where you had to decide exactly what you needed to stand on the ground before you could get started on a project. Virtual machines softened that blow somewhat so that we could start to have a little bit of abstraction between the virtual machine and the bare metal, so we weren't tied directly to the processes. Containers is where most people are today. And a lot of this talk will be about how containers apply to this area. But we can imagine going into the future, containers still, we're thinking about a runtime running somewhere. It might be a container image that's being run somewhere in a container platform. Moving into the future, of course, completely serverless and function as a service is likely to be what we'll be talking about in years to come. So the chart you'd have seen many times in the previous sessions would have been this one, talking about Agile integration architecture. And you can very quickly see that the integration, the darker blue pieces of the architecture are moving to a more containerized type of environment, and they'll have the ability to take advantage of the scaling capabilities of a containerized platform. You can also see how the API gateways are starting to break up and federate as well, and we'll talk about the different effect that it has on that too. Just taking a big step back though, first of all, clearly I'm going to be talking a lot about containerization here. We're focusing in on scalability and optimization that we can get from a container-based platform. But we certainly shouldn't be walking into containerization thinking that that is the reason we're doing it. It certainly helps in that aspect. It certainly helps to give us an abstraction from the underlying hardware. But to be successful in the containerization strategy and the containerization program, you need to be looking at many other aspects of what containerization brings to the table, not least breaking out into more fine-grained deployment and pipeline automation and writing disposable components so that you can get the kind of agility and productivity benefits that you'd expect from moving to containers. So yes, absolutely, containers bring this to the table, but that's not the only thing they bring, and it needs a broader picture to get that. So if we take a plain look at the difference between, say, a virtual machine environment and a container-based environment, we can certainly see that we're deploying smaller features. We've perhaps broken our application down into smaller pieces, and we're running those in lightweight containers. And that phrase, lightweight is a little bit tricksy because it can tend to lead us into thinking, oh, well, these things are faster. These things have higher performance. But if you look at the number of layers of infrastructure and hypervisors and guest operating systems and so on either side of this diagram, at a very high level, there's not that much difference. You're still going to have to go through quite a lot of layers to get down to the actual bare metal. So again, what containers is bringing to the table is not that we get a better performance of the application that we're running against the hardware. It's the fact that we can optimize and scale it much more effectively and much more elastically. And I think getting that straight is really key, so we don't start drifting into a containerization exercise, thinking about it in terms of raw performance against hardware, whereas in reality, if that's what you're looking for, you should just simply install on the hardware in the first place. What containerization is bringing to the table is this elastic scalability. So let's just take a look now at a typical traditional topology. What would you have to do to build a topology? You'd have to set up your servers, perhaps in an active-active pair. You'd have a high availability manager. You'd perhaps spread things across multiple availability zones. So you'd have a high availability manager and spread cold resources perhaps across another availability zone. It's all your own configuration. Setting up of the load balancing across those servers, deciding when they're up and when they're down is all your concern. A container platform is bringing all of that knowledge that we've been building up over many decades to the table for you as part of the platform. It knows how to do multi-availability zones. It knows how to load balance things across containers. It already knows how to make sure that it's got the right number of the replicas running, and it can increase and reduce those as needed. So all we really need to do is provide it with the container image. And the container image is something that's highly portable, that can run on any container orchestration platform, and then give it a set of rules. And I've deliberately treated these as sort of infrastructure as code, high-level rules that say, I want to have, in this case, I'm trying to replicate what I've got on the left-hand side. So I'm going to have a minimum of 2 and a maximum of 2, spread across zones, balanced evenly. And I've now got effectively the same as I had on the left-hand side, but I've defined it logically, and then I've just let the container orchestration platform get on with creating that. One of the biggest differences, of course, is the fact that containers start so fast. So they can effectively, instead of having a cold extra server, they can reinstate something on failure immediately. And that, of course, is the same capability that they're using for the dynamic scaling, so they can scale up. Now, of course, all I've done is recreated what I had on the left, but I've done it in a way where I'm taking advantage of the orchestration platform. What's much more likely is that I'm going to break that container up into many, many separate containers, each with, and we're talking about scaling, so in this case, each one with a different scaling policy. So up on the top right there, I might have something that can scale up to 9 replicas. Now let's bring this back to integration. So we've been talking generally about containers. These could be, an enterprise service bus that used to have 400 integrations in it. We've now broken it up to have a handful of integrations in each container. I'm now assigning different scaling factors to each one of those groups of integrations so that they're going to have different kind of properties on them. So I'm almost completely abstracted from the physical resources that are sitting underneath this, and I'm just giving it logical conditions to help me to scale things up and down. So what's going to benefit from this kind of elastic scaling? It's going to be any kind of workload that is sporadic or volatile, where the workload is varying, because then we can have the workload shifting across between different workloads within the domain. Now, of course, integration is ripe for this in many ways, because in integration we have a number of different competing components that have different needs. We have messaging environments, we have API gateways, we have analytics capabilities that are looking after the data that's perhaps flowing through the API manager capabilities. We've got integrations themselves. Some of those are asynchronous and some of them are synchronous. So some of them might be driven, for example, off periodic batch files that are going through the system and being broken up. Other ones might be related to the activity of APIs that are being called. So we've got lots of different types of workloads with very different profiles, and so they're likely to get a really, really big advantage from working from this sort of environment. So let's just drop back to that main picture of Agile integration architecture. Look at the different components we've got here. So we've got the integration enterprise service bus on the left, which gets broken up into smaller pieces as we move towards a more fine-grained deployment style. We've got the API gateways and the associated pieces there. And the dotted lines down the bottom are also hinting at something like MQ as a transport. And then the event streams on the far right that we're talking about for feeding events up into microservices environment could be talking about Apache Kafka or IBM event streams. So we can see we've got a very broad set of different components. But what's interesting is those components actually scale very differently. So in the way that microservices applications scale, and we can see up on the top part of the diagram, we're showing some microservice applications there with different functions within the applications scaling separately. The integrations are very similar to that. They scale on groups of integrations that have related functionality, and they're growing and shrinking together and being replicated together. The API gateway, on the other hand, is much more likely to be provided as a centralized capability that's used in a more sort of multi-tenant way. So we have a set of APIs being exposed on that gateway that are independent of one another, but we don't have a separate gateway for each individual API. We have a single gateway that's used in a multi-tenant style. Now, we might have more than one gateway. We might have a gateway that sits up in the demilitarized zone for exposing things externally and one internally. Perhaps we might have different ones internally for different domains in the organization, but ultimately the gateways are multi-tenant and handling many APIs. And then the other parts of the API management capability are the same. They each are separate running capabilities that are part of API management, the portal itself, potentially the analytics. The analytics, of course, would probably be it would want to sit close to the gateway and will probably scale with the gateway, because we're going to find that the APIs, the pace that the APIs are being invoked is going to have an effect on the amount of data that's being fed to the analytics. So they're likely to spread together. And as probably Rob Nicholson will be taking on the second half of this in another week, we'll go into more detail on exactly what we've done under the covers in API Connect, our API management product, where we really have started to break it up into effectively a microservice application behind the scenes. So that the portal is a number of microservices, the API manager is a number of microservices, and so on. They're not broken up by API, they're broken up by capabilities within the API management facility. So they're very different in character in the way that they're being scaled to the integrations that we're seeing in the middle. So we could also imagine that we're deploying onto multiple different environments. So we're going to have perhaps a group of containers for the application development team who are working away at building new applications. And then there'll be an integration development team that might have perhaps App Connect Enterprise and some API management capabilities that they're working on developing new things for. And then those are going to be brought together into various different environments, system test environments, UAT environments, performance environments, each needing different amounts of containers and dynamically changing amounts of containers as they go forward. And these ultimately are all sitting on a set of hardware that is completely abstracted from the platform. So we can keep moving things around. We might have a different Kubernetes cluster for production, perhaps for isolation reasons. But we do begin to wonder here whether environments, instead of being actually separate physical boxes that are dedicated to a particular purpose, in this situation, an environment is really just a set of permissions that are given to a group of people to say you're allowed to deploy containers into this particular namespace. That's a logical namespace within a Kubernetes platform. And so really the environments are more about a set of permissions, and the container platform is then finding resources underneath the scenes in order to deploy those requirements out. And of course, those requirements may change. We may need more power for some tests we're doing in the system test environment or the performance environment. We may need to adjust the proportions. We might need to introduce a whole new environment, like a POC environment that's only temporary. And because we're so abstracted from the underlying hardware, we can do that. We can just let Kubernetes work out where it can place these particular capabilities and move the environments around and change them and stretch them. So again, an environment is no longer a solid requirement that's based on a specific set of CPUs. It's something that's much more fluid. We're fluid across different types of components, and we're fluid across the different usages in different environments as well. So whilst we're talking happily about scaling and we're suggesting that we can get this kind of elastic scaling from a container environment, in the integration space, we're never working in isolation. This is one of our big challenges, is that we could go crazy getting the best benefits we possibly can out of running all of the integration infrastructure on top of environments like Kubernetes. And we'd still be caught out by the fact that the systems we're connecting to may not be able to scale at the same pace. People are writing microservice applications with the desire to be completely decoupled from those back-end systems. But of course, if they're making API invocations through a gateway and then through the integration that ultimately gets them to that system of record, then they are dependent through that chain on the availability and the scalability of that system of record. So really what we're starting to see is a move, not away from APIs, but complementary to APIs, of using event streams as well. So most systems of record have events flying around the back-end systems, probably on MQ topologies, and those can be leveraged and placed onto Kafka queues, or new events can be picked off that can be sent up into the microservices environment. And then the microservices can build their own data stores that are completely independent of the back-end systems of record. And so long as they can accept the eventual consistency and the race conditions and things like that in their design, then they can take on that pattern. If they need to have the absolute latest and up-to-date data, then maybe they go through the APIs, or maybe they go through the APIs for the simpler use cases, or the ones where the availability of the back-end system doesn't matter so much. So providing that sort of scalability comes with the need to implement these more subtle patterns of things that are essentially caches of data up in the microservice tier. Now, I have picked out a slide from a much older presentation of mine that focused on this invocation chain challenge, because if we want to, again, scale things up at the top end of the invocation chain, the device, the number of devices that are consuming a particular API, number of consumers, we've got a number of different layers that we could do that in. I've just been describing how we would do that in the microservices layer, perhaps an engagement tier layer, but there's many, many other layers that we could perform caching in to take some of the load off the back-end system and enable that scalability to happen towards the top end of the stack. Now, I'm not going to spend, this is not a session purely on caching, and if it was, then we could go through this slide in some detail, but the text is there for you to chew on. But the point being that at each layer within that invocation chain, there are advantages and disadvantages. The simplest point being that the more towards the bottom of the chain you get, the simpler it is to handle the idea of invalidating the cache and having the cache close to the business logic that you're working with. But of course, the less benefit you're gaining because you're further down the invocation chain already. The further towards the top you do it, the better benefits there are in terms of reducing the latency, but the more complex it is to work out whether the cache is still valid, whether you have your data integrity still intact. So there's plenty to think about, but certainly when we start thinking about scaling and automatically scaling down an invocation chain, we need to take those sort of things into consideration. Another aspect is that the back-end system may be able to take the overall throughput that you're dealing with, but it can't handle the peaks and the troughs that it's getting. So the high concurrency perhaps that's coming through is what's causing the scaling to fail. And so you're unable to scale simply because you're making the back-end system thrash when you get the concurrency too high. Now, the obvious thing to do there is to try to throttle the back-end system. Throttle back-end system so it only has a certain concurrency coming through. If that's the only thing you do, however, then it can be that you lose out on the opportunity to have some more subtle kind of throttling capabilities. And what we've brought in with concepts like API management is enabling us to also do consumer-based throttling as well. So we actually have, because if you imagine if you just did the consumer-based throttling, you can fairly quickly see from this diagram that we've got 700 requests per second that could come through as a potential total if everybody hit the API at the same time, whereas the backend system can only take a maximum of 500 per second. Now, if we've got both provider and consumer throttling, then we can handle both scenarios and shape the workload in both ways, both in terms of controlling the consumers, having different capabilities and different offerings to different consumers, but also still protecting the back-end system. So ultimately, we typically end up in a situation where we need the throttling to be facing in both directions, consumer-based and provider-based. I've managed to get through this far about talking about scaling, and I haven't yet mentioned persistence. And persistence is always the fly in the ointment. So it's much easier to talk about scaling something when it's stateless, talk about scaling gateways, talk about scaling stateless integration. But what about things like MQ and Kafka or IBM Event Streams, as we've created it as a managed product? How do they manage? Because they have to store things onto a disk, and ultimately somehow you've got to get the scaling in the disk underneath. And there's a dichotomy here between sort of the traditional shared persistent data that you'd find under sort of typical MQ topology or under a typical database topology, and then on the right-hand side, the sort of more modern approach to it, but with its own disadvantages as well, which is where we say, well, instead of having a shared persistent disk that we have to probably spend quite a significant amount of time and money and configuration on, perhaps we can use local disks and have replication across those local disks in order to have a sort of redundant architecture that allows us to have things perhaps multi-active as well. And that allows us the opportunity to scale up in a horizontal way that we weren't able to do before. Now, I should be careful that we don't read into this chart that the right-hand side is Kafka and event streams and the left-hand side is MQ, because in fact, MQ also has a mechanism with RDQM. So replicated data from queue managers, which allows it to do something that's approaching what's on the right-hand side as well. So there are modern ways of working on both sides with the technologies. But what we do need to respect is that there are pros and cons with both of these different styles of delivery. And so we need to work out what the key essence is of the scaling that we're trying to achieve with the stateful component. So just rounding up then, there is a difference, of course, between Kafka-style events we have in IBM Event Streams in the top half of this diagram, and the messaging style that we have in MQ. And I think there's some real subtleties around what we mean by scaling in those environments. We can easily talk about Kafka in the events territory having very scalable consumption. And it certainly can, in terms of it can have many, many consumers looking at an event stream and all reading the same messages off there. But if you get to looking at a consumer group, for example, a group of consumers that are trying to between them process the entire event stream, actually MQ does that in a way that can be expanded much broader, whereas Kafka actually has some limits on how many consumers it can have in a consumer group based on the number of partitions. Now, I'm dropping down to some quite low-level details quite quickly there, but the point I'm trying to make is that depending what it is you want to scale, you'll get different benefits from event-style paradigms and messaging-style paradigms. So with that, I am just about out of time, and I don't think I've left any time for questions, Jason. I do apologize. I suspected that might happen. As you promised, though, we will make sure we pick up on those questions afterwards and chase them down.
Thank you, Kim. Yeah, so folks, if you do have any questions, again, you can shoot me an email or shoot me a message in the chat, and I'll just be aggregating everything together when the call concludes, and we'll get you the answers that you're looking for. The one last thing I would ask you to do before we depart, if you wouldn't mind just taking a quick look at the poll that I'm about to open and just give us some feedback on the session, that would certainly be appreciated. And also, as I alluded to at the start of today's session, there will be part 2 next week. So if you found today's webcast to be informative, highly recommend that you come back again next week, as we'll be wrapping up this mini-series. So thanks again for Kim leading today's session, and hope you will all be able to rejoin us again next Friday. Take care, everyone.